Welcome to Little English Studio, the channel where history, culture, science, and the wonders of our world come alive in clear and engaging English. Today, we are embarking on a journey across Northern and Eastern Europe to explore a truly remarkable scientific achievement, the Struve Geodetic Arc, a chain of triangulation points stretching over 2,820 kilometers from Norway to the Black Sea. This monumental project, conceived in the early 19th century, is more than a set of markers on a map. It is a story of human ingenuity, international collaboration, endurance, and the quest to understand the very shape of our planet. In this video, we will uncover the life of Friedrich Georg Wilhelm Struve, the dedication of his assistants, the technical challenges of the survey, the historical context of Europe at the time, and the lasting legacy of one of the world's greatest geodetic projects. Friedrich Georg Wilhelm Struve was born in 1793 in Altona, a small town in northern Germany that was then part of the Danish kingdom. From a young age, Struve displayed an extraordinary aptitude for mathematics and astronomy. His fascination with the stars and the geometry of the Earth would eventually lead him to one of the most ambitious scientific projects of the 19th century. In 1816, he began working at the Pulkovo Observatory near St. Petersburg, Russia, which became the center of his geodetic and astronomical work. Struve's vision was groundbreaking: to measure a meridian arc extending from northern Norway down to the Black Sea, a task that would allow scientists to calculate the precise shape of the Earth. At the time, geodesy, the science of measuring and understanding the Earth's size and shape, was critical for navigation, mapping, and scientific understanding. Accurate measurements were essential not only for astronomy, but also for the political and economic ambitions of nations, as maps defined borders, trade routes, and spheres of influence. The project required more than brilliance in mathematics; it demanded leadership, diplomacy, and endurance. Struve had to coordinate teams across multiple countries, navigate political boundaries, manage logistical challenges, and ensure the accuracy of data over thousands of kilometers. It was, in every sense, an international scientific endeavor, one that laid the foundation for modern geodesy. The Struve Geodetic Arc consists of 265 survey points, carefully selected across 10 modern countries: Norway, Sweden, Finland, Russia, Estonia, Latvia, Lithuania, Belarus, Moldova, and Ukraine. Of these points, 34 have been preserved as UNESCO World Heritage Sites, a testament to their historical and scientific importance. Each survey point was meticulously positioned to allow lines of sight to neighboring stations. From mountain peaks to open plains, from remote islands to forests, Struve's team sought locations that combined visibility with accessibility. At each site, surveyors measured angles between landmarks using precision theodolites, calculated distances through trigonometric formulas, and recorded data with extraordinary attention to detail. The process of triangulation was painstaking. Teams had to carry heavy instruments over challenging terrain, often enduring harsh weather and difficult conditions. Mountains, dense forests, rivers, and lakes presented constant obstacles. Surveyors worked tirelessly, setting up markers, observing angles, repeating measurements, and verifying calculations. Every error could have compromised the integrity of the entire chain, yet the precision achieved by Struve and his team was remarkable, demonstrating the extraordinary skill and determination of these scientists. Struve's work combined mathematical brilliance with practical ingenuity. The instruments used were the most advanced of their time. Theodolites allowed precise measurement of horizontal and vertical angles. Measuring rods and chains enabled accurate calculation of distances, while astronomical observations established latitude and longitude at key points. The survey was a blend of fieldwork, mathematics, and observation, a combination that demanded both intellectual acuity and physical stamina. Surveyors often faced extreme weather conditions. In Norway, snowstorms and icy winds made mountain surveys treacherous. In Ukraine, open plains exposed teams to sun, rain, and wind. Remote sites required long marches, sometimes over days, carrying fragile equipment. Despite these challenges, the project progressed methodically. Struve established standardized procedures for data recording, verification, and calculation, ensuring that the measurements maintained consistent accuracy across thousands of kilometers. The Struve Geodetic Arc was more than a scientific achievement; it was a cultural milestone. Europe in the early 19th century was a continent of intellectual ferment and political upheaval. The Napoleonic Wars had redrawn borders, new nations were emerging, and science was becoming a tool of both knowledge and statecraft. Struve's project symbolized a new era of international collaboration. Surveyors from different countries worked together despite language barriers, political tensions, and geographic challenges. The Arc was a bridge between nations, a testament to the shared pursuit of knowledge that transcends borders. Its completion influenced not only geodesy and astronomy, but also education, mapping, and navigation. The data gathered by Struve's team would be referenced for generations, helping define modern cartography and advancing scientific understanding of the Earth's dimensions. Each station along the Struve Arc has its own story. In Norway, surveyors climbed jagged fjords and snow-covered peaks to position markers with perfect sightlines to neighboring points. In Finland and Estonia, dense forests tested patience and ingenuity as teams cleared lines of sight without modern tools. In Belarus and Ukraine, open plains provided fewer obstacles but demanded precision over vast distances. In each location, surveyors battled not only the elements but also logistical challenges, transporting instruments, feeding teams in remote regions, and coordinating calculations across countries. The human story is as remarkable as the scientific achievement. Generations of surveyors followed Struve's methodology, dedicating years of their lives to this meticulous project. Letters, journals, and reports from the period reveal not only technical details, but also the lives, struggles, and triumphs of those who contributed to this extraordinary endeavor. Today, 34 original Struve Arc points are recognized as UNESCO World Heritage Sites, preserved across 10 countries. Visitors can explore these sites and see plaques, monuments, and markers commemorating Struve's achievement. Many points are located in scenic landscapes, offering both historical insight and natural beauty. Walking along the Arc, one can imagine the surveyors of the 19th century observing distant peaks, measuring angles, and connecting points with extraordinary precision. The Arc's legacy extends beyond tourism. It continues to influence modern geodesy, satellite mapping, and scientific research. Struve's meticulous records provide a historical baseline for measuring changes in the Earth's crust and monitoring tectonic movements. The Arc also serves as an enduring symbol of international cooperation in science, a reminder that curiosity and collaboration can overcome geographical and political boundaries. And that was the story of the Struve Geodetic Arc, a remarkable chain of scientific triumphs spanning thousands of kilometers across Europe. From mountain peaks to open plains, from Norway to the Black Sea, this monumental project reflects the power of human curiosity, endurance, and international collaboration. Thank you for joining us at Little English Studio. If you enjoyed this journey, don't forget to like, comment, and subscribe to explore more of the world's history, science, and culture, all presented in clear and engaging English. See you in the next video.